All right, my people, let's check out some capacitors in series. So remember, a capacitor's job is to store charge. And here we've got a 4-volt battery in, um, in series with a 6 microfarad and a 12 microfarad capacitor. To find the equivalent capacitance for a series of capacitors, we use this equation here. Notice that that's similar to resistors in parallel. Another important equation we're going to need is Q, which is the charge, is equal to the capacitance times the voltage. So now if we take these two resistors in series and plug it into our equivalent capacitance equations, we get a value of 4 microfarads. So the equivalent circuit would look like this. So these two capacitors essentially become a 4 microfarad capacitor. Now, one thing we need to know is that the charge on one plate of a capacitor in series is the same as a charge on each of the capacitors and the same as a total or equivalent capacitor. So we'll use our equation Q equals CV on our 4 volt and 4 microfarad equivalent circuit. There, so we plug in the 4 there, 4 microfarads there, and then we end up with 16 microcoulombs. So that's how much charge appears on each side of this capacitor. The charge of each capacitor, therefore, is 16 because we go back to this concept that the charge on one plate of the capacitor, each of these capacitors, is the same as the charge on the on one plate of the total capacitance or total capacitor. All right, so what we do is we'll redraw this circuit over here and notice that we now have our 16 microcoulomb charges there. And then we can put that in our QCV chart. Notice we've got 16 microcoulombs, 16 and 16 here. 16 because that's what we calculated here, okay? And each capacitor is 16 coulombs. The total capacitance is 16 microcoulombs. Then we go about using our QCV chart, okay? Our QCV chart. To figure out what our voltage is, we take 16 divided by 6, 16 divided by 12, and 16 divided by 4, and we get our voltages on each capacitor and our total voltage. And notice this makes sense because our two voltages should add up to our total voltage. So I want to come back to this idea of what is the charge on one plate of the 6 microfarad capacitor. So this is the 6 microfarad capacitor. This 16 microcoulombs is the charge on each side, on both the positive and the negative side. And that's it.